Hello everyone. Previously we have solved examples on modified Goodman's theorem, but they were only in single dimension. Now last part of the lesson is that in which you have to solve according to modified Goodman's theorem, but the problem is on two dimensional stresses. There is two types. The first type is in which tensile stress is acting in x as well as y direction, and the second type is tensile stress is acting in x direction and torsional shear stress is acting in the second direction. Now starting with the first type, let us see the diagram as shown in figure. We can see, let sigma x max and sigma x min be the stresses acting in x direction. Similarly, sigma y max and sigma y min be the stresses acting in y direction. Therefore, there are in all total four stresses acting in component: sigma y max, sigma y min, and sigma x max, sigma x min. Now we can find in x direction x mean and x amplitude. Okay, sigma. For this we know the formula: sigma x max plus sigma x min divided by 2, sigma x max minus sigma x min divided by 2 for amplitude. Similarly, in y direction, sigma y max plus sigma y min divided by 2 for mean, and sigma y max minus sigma y min divided by 2 for amplitude. Now as we know, we have two mean and two amplitude in x and y direction respectively. To combine two mean and two amplitude separately, we use a distortion theory of failure. According to this theory, sigma mean is equal to in square root of sigma x square sigma x mean sigma xm square minus sigma xm sigma ym plus sigma ym square, and for sigma amplitude, sigma xa square minus sigma xa sigma ya plus sigma ya square. Now the problem we have is sigma m, sigma amplitude we have found separately. Now the sum is same as previous one. For this we solve tan theta equals to sigma a upon sigma m. We have both the values, therefore we get the value of tan theta. We know tan theta is also equal to SA upon SM. Therefore SA is equal to what? Tan theta into SM. Putting this value of SA in equation number 2, we can get only SA as the unknown. Therefore we can solve the equation and find SA and SM respectively. Now we also know that sigma means the applied stress is equal to what? SA upon Fs. Now we got the sigma A, which is equal to 32 m by pi d cube, from which we can find the diameter. Now going with the second time, in which one direction is applied with a tensile stress and the other direction is applied with the shear or torsional shear stress, torque. Now let sigma max and sigma mean, sigma x max and sigma x mean be the tensile stresses acting in x direction, and tau xy max and tau xy mean be the torsional shear stress acting in xy direction. Now we find mean and amplitude in x and xy direction separately. For mean and amplitude in x direction, we know the formula: sigma x max plus sigma x mean divided by 2, and for amplitude, sigma x max minus sigma x mean divided by 2. Similarly, for shear stress, tau xy amplitude is equal to what? Tau xy max minus tau xy mean divided by 2, and mean is equal to tau xy max plus tau xy mean divided by 2. Now we have two mean and two amplitude separately, two amplitude and two mean separately. For solving or getting combination of one, we can get using distortion theory of failure. Therefore sigma m is equal to what? Square root of sigma xm square plus 3 tau xym square. Similarly, for amplitude, sigma a is equal to sigma xs square root of sigma xa square plus 3 tau xy a bracket square. Now the sum goes to similar type as previous one. Now we solve tan theta equal to sigma a upon sigma m. We get the value of tan theta. We know tan theta is equal to SA upon SM. Therefore SA is equal to tan theta into SM. Now putting the equation or putting the value of SA in this equation number 2, we get the whole equation in terms of SM, which is unknown, and we find the SM. Now with this formula we get SA. Now SA and SM are found or known. We calculate sigma a is equal to SA upon Fs, and sigma a is equal to either 16t upon pi d cube or 32 m upon pi d cube. Using these two formula, we determine the value of D. Thank you.